So economists have this thing called the damage function, which basically translates something like, let's say, a temperature increase to a cost. So the outcome, let's say in terms of electricity in kilowatt hours, and there is a damage function that does that translation, which is shown here without adaptation. So you can see that with temperature increase, the cost there is the damage function is has a larger amplitude, and with adaptation you basically flatten the curve of the damage function as well. So then you look at the outcome as electricity in kilowatt hours, which can be converted into a cost based on the price of the electricity you have to pay for. Right? So let's say we have a pre-climate change variability here that's shown in a gray line here below, and climate change happens over a certain number of years where you are trying to estimate the cost of the additional ton of CO2, for example, which caused this climate change, temperature change. Not only has temperature gone up, but it has also become more variable in this case. Okay, so if you use the wrong damage function that is corresponding to the pre-climate change value, then you are going to end up here with a very little thin curve that you cannot barely see in gray, which says there is no change in the outcome. So which means your damage function better take care of the change in climate. It could be something like air conditioners in a city like San Francisco, which typically never really needs air conditioning because it's a nice mild climate throughout the year. But as climate change happens, instead of having spikes of temperature for a day, during the day, you might begin to have sustained increases in temperatures during the day that last into warmer nights as well. Then you cannot sleep, or whatever reason you cannot work comfortably, you cannot protect your computers well enough, and then you begin to invest in air conditioning. So those kind of things go into this damage function. We will see in a minute exactly what we know about the damage function for various impacts. Okay, so if on the other hand you choose the post-climate change temperature range for estimating the energy use outcome, without adaptation you will get the change here, and with adaptation, without adaptation you are here, and with adaptation you are down here. So adaptation here could mean increased number of air conditioners because you have warmer temperatures. So obviously your electricity consumption has gone up. So it's kind of confusing because you have to say, we keep saying we must adapt to climate change, and buying an air conditioner for warmer temperatures is an adaptation, especially in a country like India where income grows, people want air conditioning because it's hot anyways and it's getting hotter. Then adaptation is actually costing a lot more. So the damage function there is actually better without adaptation, but then other externalities kick in where health impacts could be worse, morbidity and mortalities go up, productivity goes down, and so on and so forth. Okay, so those are the kind of issues involved in damage function. So this is from Quantifying Economic Damage from Climate Change, a paper by this author Aufhammer, which is apparently very good according to the author himself. Coverage of the damage function literature showing what we do and do not know about damage functions for different sectors of the economy and beyond. So not only quantifiable market goods but also non-market goods, and here are the sectors, here are the plausibly causal estimates, so relating to CO2 emission and impacts on this particular sector. Adaptation, was it included and stressed or not? And whether the coverage of the study was global or not. Was it done for a particular place like the Midwest where a lot of corn is grown, or wheat, or whatever, or also included countries in the global south, for example. That's important for how the damage function is estimated. So agriculture, there are studies that did all that, global causal estimates, adaptation stressed, global coverage. Forestry, not at all. Species loss, not at all. Non-market good. Forestry is a market good if you cut the tree and sell it, but if you just leave it there and it's taking up carbon and it's offering a pleasant environment for people to visit, then how do you put a value on it? What is the value of a tree that's standing? If you cut it and make furniture, you know the value. Otherwise, how do you put a value on it? So the damage function from climate change to forestry is not very easy. Species loss, as we said before. Sea level rise, it's not been done globally because sea level rise is specifically a regional problem, a local problem. Energy, human amenities, adaptation, maybe. Morbidity, mortality has been looked at quite a bit. Migrations, causal estimates are made, but adaptation, not easy. How do you prevent climate-related migrations? Crime and conflict, not so easy in terms of damage function or cost, quantifying economic damages from climate change. So crime and conflict, for example, can be very controversial because there is evidence that warm temperatures lead to higher crimes and more violent behavior. Okay, and conflicts also happen with not only warming but also persistent droughts, like the Arab Spring and the Syrian war and the conflicts in Darfur, and many such situations have been argued and quantified to some extent to be related to climate change impacts. Okay, but how do you estimate the additional cost if a region like Syria is already a unstable region and climate acts as a multiple stressor which tips things over into armed conflict? Then how do you assign economic value to the additional impact of climate change on these conflicts? Productivity, probably much easier. Water consumption, surprisingly, not done yet. Pollution, storms. I wanted to go through this because you can see the range of market and non-market goods, and you can begin to think of the difficulties you would face in coming up with quantitative estimates of economic damages from climate change. Okay, so I'll stop this here and do the social cost of carbon in the next podcast, but you are beginning to get a sense of the difficulties of putting value of impacts of climate change on not only non-market goods but also market goods and societal geopolitical problems like crime and conflict.